For a while, I've been wanting to replace the introduction music with something a little bit more amped up. And a few weeks ago, I was on a nostalgia trip, and I came across some old music from a game from the mid-90s. For those of you who remember the 90s, or if you were around in the 90s and you played computer games on platforms like the Amiga, Atari and some of the others, you may recognise the new intro music. Because, you know, back in the day, some of my friends and I were in the computer club and they used to rip music from the games, and they were in this format called Pro Tracker or Sound Tracker. And one of my favourite pieces of music from the games was a game called Project X, and the author of the music is Allister Brimble. And I found it on YouTube, and Allister Brimble has remastered many of the old computer game music that he created and has released it as a paid-for product. And I just thought, you know, I wonder if he would mind if I could use a short sample of it in the intro, because it really is my favourite Pro Tracker tune of all time. And he said that I could. So thanks a lot to Allister Brimble. Allister's been in the computer games music industry since I was a kid. And he's created the music for loads of different games. And still today, he creates music for some of the biggest games around. So you can check out his portfolio online. You can also listen to some of his music on YouTube as well. And if you like the music that you hear and you enjoy some of the music from your favourite games, there's a good chance that Allister created it as well. So you can download, you can buy the music from Allister as well. So check it out. You can find him on YouTube and you can check out his website as well. So the music that we're going to use in the new introduction is from the game called Project X back in the mid-90s. And thanks again to Allister. So let's hear the new intro. Hello, I'm Stuart Winter, the platform architect for Slackware on the ARM platform. Now this week's task is to install this into one of my RockPro64 builder machines. Now what is this then? This is a 2-port SATA 3 PCIe card. Now a while ago the Pine64 company sent me a couple of RockPro64s and I did an unboxing video for those. And the thing is though, I haven't actually set them up yet. Because I've been waiting for the case to arrive. So I've ordered myself another RockPro64 NAS case because I really like these cases. And you'll see when I show you in a bit, they're really easy to work with. So I've been waiting for that. I just got that the other day. So yeah, I've got 2 RockPro64s spare, and I just wanted to get ahead of the curve a little bit and just prepare one of the RockPro64s to be the next stable builder for Slackware ARM. Now the thing is though, is that the existing build machines have a particular Marvel card, which the vendor is called Marvel. And you can find out which one it is by looking at the RockPro64 installation guide. Now the thing is that I bought those when they were on sale on Black Friday last year or a couple of years ago or something. And now they're more expensive. And the thing is, I thought, well, you know, there must be cheaper options because I think it's a 4-port SATA board. And I only have one SSD drive in there, so I really don't need the other 3. So I thought there must be another option, and there is. So this card is a 2-port SATA card, so it's cheaper. So I thought, you know, okay, let's go down the cheaper route, and it also means that we get to test some extra boards, so I can put them on the supported hardware list. Because you know, obviously, there's no point in paying for a 4-port SATA board if you're only ever going to have one drive, like I am. I don't think in most of these. I mean, some of you guys might want to, use all ports because you can easily use Slackware AArch64 and a RockPro64 for doing storage needs. For your storage needs, like running an NFS server or CIFS. What would you call it? Samba server. So it works really well for that stuff. So you could indeed build yourself a NAS or some kind of file server out of it. But for me, I only have one disk. I have quite lightweight requirements on the ARM platform. But nonetheless, on mine, I've only got one disk. So I wanted something that was a little bit cheaper. So what I've done is you'll see on the screen, so this is the Amazon listing that you're looking at the moment. If you want to support the project, and thanks to those of you who already have, in fact, your support is paying for this particular card. So if you look on the screen, you'll see that it says Linux is supported. The first thing I did was just Google the chipset name, and there wasn't a lot there. There was really only several pages. So I didn't really have any particular concerns, but I wasn't particularly confident either. But people seem to be using them in in some RAID devices, and it seems to be successful. So I wasn't too concerned, and it should be supported because the card supports this particular storage controller supports AHCI. Now, if you don't know what AHCI means, it's basically just, in a nutshell, it just means it's a standard, it's a common language that you can use to speak to storage controllers like this. So all of the modern storage controllers support AHCI. Because this one does support AHCI, I'm pretty confident that it will work. It doesn't mean that it's going to work reliably in the RockPro64. It doesn't mean that it'll work reliably in an x86 either. It could be that, people don't use them that much, and so when you put big, really heavy workloads through it, the thing could fall over and damage your data. I'm not saying it will. I'm just saying that these are the kinds of problems I've had to deal with through the years, so I'm always still a little bit cautious. So the first thing is, let's have a look at the kernel. Now, I'm on one of the build machines, so I'm in the kernel package directory. Okay, so inside of this directory is a script called do src update. Now, I'm just going to run this, and what this does is this unpacks the Linux kernel source. It applies any patches that are available, and then it updates the configuration, the kernel configuration file. And it also updates the version number of Linux in the ARM package build script. So this is the way that I update the kernel package in Slackware ARch64. And you can use this script as well. If you just download the Slackware ARch64 source tree, you can run this script in there. You don't need to install anything else. And you can do exactly the same thing as I'm doing at the moment. Okay, so it's applied all of the patches. And this is important as well, by the way, at this present time. This is not an issue. But back in the day when on ARM32, at some phases I'd apply patches to actually create support, rather than what we do these days. It's mostly, many of the patches are, well, at least I should say, the patches that we're applying in Slackware ARch64, these patches generally fix things or, apply enhancements. Whereas back in the, back in the 32-bit days, some patches were actually adding in support from new. Now, the thing is that when you update the kernel config between versions, the kernel config, well, it configures the kernel, so it sets up how you want the kernel to behave and what features are included in it and that kind of stuff. And if you updated the kernel config to align it with the new version, you take your old kernel config and you tell the Linux kernel, please update my kernel config. So when you do that, it asks you, generally lots of questions. So you run make old config, and then it says, do you want to add this? Do you want to change that? And you just go through the list. This script actually does that for you, but in this instance, there haven't been any config changes, so it's just updated the kernel config and saved it. But what would happen is, with the patches, is that if you did the make old config update process first, then the additional kernel modules that you might have enabled or configured would be removed from your new kernel config. So you have to always apply the patches first and then do make old config subsequent to that. So this is the script that I use. It prepares the Slackware ARM kernel package to build, basically. It sets it all up. And it unpacks, I think it's in here, yeah, that's it. So this is the configured and unpacked Linux source for Slackware ARch64. So what I'm going to do now is load up one of the several kernel configuration tools, and I can show you where the AHCI support is, just in case you're interested. Okay, so let's scroll down to, where is it? It's device drivers, isn't it? Yeah, there it is. So it's because this is so big, I'm used to seeing it on a much smaller screen, so I've got everything in one go, and I can just scan the list and then select the right one. Okay, so serial ATA, there it is. Okay, So you'll see that in here there really isn't that much. In fact, actually, let me just see if I can make that a little bit smaller. Oh, that's better already. Yeah. Okay, cool. That makes my life easier. Okay, so this is really everything that's available for the libata driver in Linux, the kernel module, or rather, I should say the support. Let's say that. So the thing is, as you'll see in the Slackware ARch64 kernel config, we've enabled pretty much everything. We don't want any of this legacy stuff, and I'm certainly not going to include very experimental things in the kernel unless there's a really good reason for it. So yeah, we've included everything really. And this module here, so this is where we configure the kernel support for AHCI. So as I said before, AHCI is basically a common language to address storage controllers. And this is where the where the support for that is in Linux. And so you'll see that we have it enabled in ARch64. So we should be good. So let's see which device drivers are currently supporting the existing Marvel card in this machine. So this dastardly is one of these RockPro64s. Now, if we wanted to see which kernel modules are involved, or which kernel drivers are involved in supporting the existing PCIe Marvel storage controller in this RockPro64, we can use udev adm. Info, no, I think is it AD or AN? I can't remember actually. Let's have a look. I think let's go with AN. I might have that wrong. Oh no, that's it. Okay, so this tells you everything that's involved with to make this storage controller work on the platform. So it gives you loads of information here. Now the thing that we want though at the moment is just the drivers. Yeah. Okay, so if we just filter everything but the drivers. So you'll see what's involved. So you've got a kernel module called SD, there's another one called AHCI, and there's these other ones as well. Now the SD mod is the generic info. Now I know that happens to be called SD_mod. So that's the SCSI driver for the actual, for the disks or for the storage. Now the other one that we're interested in is the AHCI driver, which is one of the ones I showed you looking at the kernel config. So hopefully that's the driver that will support this little card. So what we're going to do next is, because I'm not entirely sure it's going to work, pretty confident, but I'm not entirely sure. In this machine, I don't want to have to pull it out of the rack and loads of stuff like that. So what I'm going to do is I'm going to add in the slkpbs kernel command line to the Slackware ARM kernel module loader. And that way, if it doesn't work, I can fiddle around with it and hack around on it to try and make it work and get it to boot, and then put those changes into the, back into the source tree and make it so that when I rebuild it next time, it does work. That's the plan anyway. But hopefully I won't have to do any of that. I'm just going to do it as a precaution. What I'm going to do is I'm going to edit the config and add that slkpbs, which is a Slack Preboot shell. So that's the token that we need. What I'm going to do now is reboot that machine. What you're looking at now is the output to the serial console. So some of you guys have been having a look at the slkpbs, the Slackboot Preboot shell in the forum. And yes, you absolutely need to use the serial cable for this. You can't do this with a video. And that's simply because the Preboot shell opens before it loads any of the kernel modules. That's kind of the point of it, or part of the point of it. Is to be able to hack around with the kernel module lists and get stuff working. So something's gone weird on there. It's because sometimes this does this if you have any interference on the serial port. So some of these cables are a little bit dodgy. Some of the cheap serial connectors I've got, they're a little bit dodgy sometimes. So I think that's what's happened there. But that's fine. I just wanted to reboot it into the U-boot shell so that I can then go and remove, do the actual physical work. I'll just pull the plug. Here is the RockPro64, or whose card we're going to remove. This is some of the Slackware ARM build machines. As you can see, it's a bit of a mess at the moment. I've got to sort out the power and all that kind of stuff and make everything a bit tidier and easier to work on. But at the moment, it works. When I've got time later this year, I'll probably do that. Okay, just a couple of points to note here is this RockPro64 has a, I'm not going to lift it up, but it has a 3.5-inch spinner in here. I do prefer spinners. I actually said previously that it was an SSD. I forgot. This one, I don't know if you can see that in shot or not, but yeah, you can. But this one here is Bladswede, so this one has an SSD and this one has a spinner. I do prefer spinners because usually you get more warning when they're going to break, whereas SSDs tend to not do that. But you know, you've got monitoring software and all that kind of stuff, but I don't have that on the build machines at the moment. It's kind of unnecessary. All right, yes, the other thing to notice is that it's powered by an ATX bench supply. So this was removed from an x86. I think I did a video about that as well, about why I've done that. But basically, it's because I power the fan separately, which is really important because sometimes the kernel, well, the interface to the fan driver just doesn't make the thing spin. So that's not ideal for a machine, for a workhorse machine that's just working the CPU hard when it's compiling packages and stuff. So I power the fan directly from the 5 volt, I think it is, line on the power supply, and I just find this whole setup really stable. So that's why I do it. Maybe I think for the next build machine, I'm going to make it more simple and just use the normal RockPro64 power supply, actually, just to make it easier and see how it holds out. But there we go. So I'm going to unpower the whole thing. That's definitely dust as this one, and hopefully you see the power light is extinguished on the card. So what do we need to do? So I'm going to physically unplug it as well, though. I think that's it. Yeah. Okay. So I need a Phillips screwdriver. And I'll tell you what, I really hope this actually works because, oh, is this a, oh yeah, it's not quite the right size, but okay. I haven't got my computer tools here, they're in the office, I think. Right, so this is the Marvel card. This is a really nice card, and I've had them now for, I think, I don't know, actually maybe a year, something like that. And this is, why can't I get that out? Hang on, let's unplug that first. Let's unplug the actual SATA lead. Is it just because it's stuck on there? Is it? Oh, no, it's okay. I thought I could slide it over and I can't. So I have to take the whole thing out. I was trying to avoid removing the screw, you see, in case I lost it. But actually this is magnetic, so it makes it easier. That should just come out. There we go, yeah. Okay, so this is the... So this is the Marvel card that's in there. What is it? It is, yes, it's 4-port SATA. So again, these are really good, and you can see this one on the installation guide. This is listed there, so you can get that one. If, by the way, I have no link with Amazon or any vendor, so buy them from wherever you want. If you want to donate to the project, please do so. You can find the links on the website and at the end of this episode as well. And again, guys, you've paid for this stuff, right? So thanks a lot. I really enjoy working on the project, and you pay for the electricity as well. So thank you very much for that. I really appreciate it. As you can see, it's a fun project, isn't it? You know, it's good. This is actually kind of like this is part of the project that I enjoy the most, actually, because most of the time it's just kind of hacking on scripts and making stuff build, which is fun, but it's not the only thing I like doing. Right, it's just switched off, isn't it? Yeah. Okay, so let's go. Let's put that in there. Yeah, I've got to sort all of this out next year. I've got some plans. I've already got the board for this, and it's going to have surface-mounted power sockets with USB and whatnot. So I can tidy the whole thing up, and then I've got stuff below which you can't see, and all that stuff. So let's be optimistic and screw it in. Now the thing is, though, in my experience, I get optimistic, I put it all together, and then you get it wrong, and then you have to take it all apart, and or it doesn't work. I've done a lot of this stuff over the years, but let's be optimistic today, because I'm sure it's going to work. It's just a storage card. How wrong could it go? Right, so let's I think we're good. Right, so let's plug that in. Oh, the other thing, actually, I've got this one for some reason. I've got one of these old HD. I don't know if you can see that in the shot. You should be able to. Just about, yeah. So this is an old HDMI. This white bit to HDMI. Yes, that's HDMI. This is to DVI. Sorry, what am I talking about? It's the wrong way around. So Yeah, so this is DVI, quite old technology, and it's converting, this little converter converts it to HDMI. And on the back end, or down on the next shelf, I've got I've got a DVI monitor. So I've got this here. It was working a while ago, but now, I don't know why, but I don't get any video. So I've been meaning to look at this for a while, because I quite enjoyed using the RockPro64 for debugging things. It's quite handy to have the console there, and it's got the keyboard and stuff. I think it's just keyboard I've got on it, which is working off of the USB on the front here. It'd be quite nice if the RockPro64 had some USB on the back as well, but it doesn't. So, okay, we've got that connected. Let me turn the monitor on as well. Whilst I'm here, I've also just opened up the serial console again from another machine below in the rack, so I can monitor it. And then what we'll do is I'll go back to the office and we can have a look again on the laptop and take over the serial console from there. So I'm just going to power this on, hopefully. So on the shelf below I have another machine on which I've got serial console access to this RockPro64. In fact, I said it wasn't working, but the video wasn't working. As you can see, it now is. So this is, I don't know what it was, something must have just been loose, I guess. But this is the monitor plugged into the HDMI port of the RockPro64. So I now have access to the bootloader. This is an x86 machine where I've just had screen running. So I know now that I can take over the serial console of the RockPro64 from my Pinebook Pro. Alright, so let's put this back in the bag with the 4-port Marvel, and we'll go and see if the RockPro64 boots. Okay, I'm back on the Pinebook Pro now, and I've just reconnected to the serial console that's attached to the Pinebook Pro. So I'll just reset the RockPro64 again, and we can watch it boot into the Preboot shell. Okay, so it's loaded the extlinux.conf, which is the bootloader config for U-boot. It's loaded in the initrd, which is the operating system initial RAM disk, or OS initrd as we call it, and the image file, which is the kernel itself. The OS initrd contains this Slack Preboot shell, or SLKPBS as the command line operator is called. And it's a debugging tool really that's built into the kernel module loader part of the OS initrd. And it has 3 stages. The first stage allows you to edit the kernel module loader scripts before they're loaded. So this is the time when you can go in and just edit those, hack on those to try and get the system working or to make it stable. The second stage is where it's loaded in those config files and it's set the lists of modules, but it hasn't yet loaded them. And this allows you to still play around and see what those lists are to make sure everything's working. Third stage is subsequent to loading all of those modules, so you can check it out. Now, for what I'm doing here today, I don't need to play around with stages 1 or 2. All I want to do, well, really just see if the system has brought up the storage properly. Can it detect the new SATA controller? So I'm just going to use fdisk to see. Oh, perfect. There we go. So you can see we've got SDA 1 and 2. So it's good. It's been detected. All right, that's good news, isn't it? The card works in Linux. The next step is to feel more comfortable that it's robust. So what I'm going to do is just put real workloads through it. So I'm going to reinstall that machine. I'll do that in a moment. And then I will build the latest Linux kernel that's just dropped today. And then that way I'll start to feel more comfortable that it's a good card. And I can then add it to the list of known good hardware on the installation guide as well. And the thing is, if anything does break, if the kernel breaks building, it's pretty obvious what's happened to it, because I'll see messages in dmessage about the storage falling over and stuff like that. If anything does break, I'll just move the workload back over to the primary builder and put the Marvel back in. So now I'm going to reinstall that build machine. Now, okay, so what I'm doing here is I've got a script that basically dumps the Slackware AArch64 installer onto the MMC to make it easy for me. Yeah, so hopefully all of that's going to work out well, and if it works after, I'll give it a week or maybe a couple of weeks. If it works well, then I'll update it on the in the installation guide, and I'll send a note to the forum as well. Okay, so that's this week's task completed, and I'll see you in the next video, which I think will be about the all-in-one installer, so I can show you how I've basically just made Slackware a little bit easier to install on ARM. And then in a future video, I'll show you the little project I'm working on to make these all-in-one installers work on x86 as well. Because most of the x86s, if not all of them that you buy these days, don't have optical media drives anyway. So to me, it kind of starts to make sense to distribute complete bootable USB images of about 5 gigs or so, and you just dump them onto your USB storage and you boot it. Basically the same way as we do on ARM, apart from on ARM we're using MMC SD cards. And so yeah, I'll show you that at some point as well. Alright guys, well again, thanks a lot for your help and thanks a lot for your support to the project. It makes it happen and it's good fun working on it, isn't it? You can do all of this stuff as well, just some bit of hardware and some reading some documents and screwing some stuff in and that kind of stuff. So yeah, thanks again, and I'll see you in the next video. Take care.